Hello, those of us in the room, and hello to everybody who is joining us remotely. Welcome to the first post-lockdown in-person Eastside AI, ML, and IoT meetup. So my name's Jim Bennett. I am now one of the organizers of this meetup. I wasn't until fairly recently, and I got kind of asked to do it by Andrew over here. So you want to say hello? Yeah, so as Andrew says, we're glad to be back in person, glad to be showing off these events. Now, this is a hybrid event. So as I said, we've got folks here in the room, we've got folks joining us remotely, watching us on YouTube. Now, we're going to be trying a few things today. As we move into this hybrid phase, we want to make sure that we can bring communities together, regardless of whether they can or indeed feel comfortable coming to an event in person. So as well as having the stream today, which is happening over YouTube, we're going to be doing virtual networking later. So after I finish all my stuff and finish off showing what I'm going to be showing you today, please join us at aka.ms/reactor-red networking for an online networking session where if you're remote, you're literally going to look into the room and then chat to people who are here in person. Now, before I kick off, I do need to cover our code of conduct. This Reactor space and our online sessions are all covered by our Reactor code of conduct. Be nice, be professional, be kind. We have a zero tolerance policy. So if you breach the code of conduct, you will be removed from the building or kicked off the stream. If you see anybody who does anything that would breach the code of conduct, anybody who does anything that makes you feel uncomfortable, tell one of us, either me, Andrew, or Casey or Irina, the event staff, or the staff at the front of the building, and we will have this person removed if necessary. We have a zero tolerance policy on code of conduct breaches. So please be nice, be kind, be professional, but also be curious, ask questions. Anybody can ask questions at any time. Interrupt me with a question. Same as if you're online, ask on the chat, and we'll get that question jousted out in the room so that we can answer everything for you. So, as I said, this is the Eastside AI, ML, and IoT meetup. You know, yes, it's Eastside. We are this side of Seattle, but say we're open to everybody. And we want to get this community growing again. We want to get people involved. So if you enjoyed today's session, come next time and bring your friends. If you don't enjoy the session, next time bring your enemies. You know, we're open to everybody who wants to join in. But please tell everybody about this, and just think of this as a community where we want everyone to get involved. We want you to share your stories. If you've got a job opening that you might think of would be of interest to the community, please come and share it with us. If you've got any other opportunities as events you want people to come to, you're putting on an AI, IoT, or ML event, you want people involved, come and share it with everybody. And most importantly, if you want to be a speaker, please let me know, because we don't want to be a meetup where every week Andrew and I are kind of trying to work out who's going to stand here and talk about something. Yeah, we want you to come and share, whether it's the stories of what you've been working on, whether it's a cool project, doesn't matter, we'd love to hear from you. And if you're a new speaker, you're not sure about actually standing up in front of a room full of folks and speaking, and you want some help and guidance, we can help you. Some of us are professionals at this. We get paid to do it, and we've done it a number of times in front of large groups of people. I think my record is 1,600 people in London. So Andrew's record is 50. Okay, so we have a range of scales of experience. But no, if you want to speak, we can help you. Provide you with the training you need, the support you need if you want to come up and share your stories. So we meet the last Wednesday of every month. That's the plan. This is the first one of these. So next month, we may not have one because the last Wednesday is slap bang in the middle of Microsoft Build. And if you're like me, you'll be probably glued to Microsoft Build. So we may adjust that one. We haven't really spoken about that. But the plan is the last Wednesday of every month we will get together. So I said, we're all hybrid. You know, be open to everybody. If you want to jump on our YouTube, if you go onto Meetup, there's a link to YouTube. If you want to join in the chat on YouTube, you can. Feel free to do so. And say we'll have hybrid networking going on in the future. Now, being kind of a reboot of this, thinking about hybrid, we do want to learn from you. So if this whole networking that we're going to do later, if that works for you, tell us. If it doesn't work for you, tell us. We want to know what works for you so we can kind of build this community in a way that works for all the members of it. So we want to learn from you. We want to learn, if you've got any new ideas you want to try, anything like that, you let us know. Some things we can change, some things we can't. You know, there was one person who commented on Meetup about not favoring Domino's as a pizza supplier. Unfortunately, that's not something we can change because of Microsoft having agreements to pay. But if anybody else wants to sponsor food that's not Domino's, you're more than welcome to come and sponsor food. Your company that wants to sponsor, that's fine. Now, say, if you want to come speak, come talk to us, we can organize that. Yes, this is a Microsoft building. Microsoft is sponsoring this event by providing the space and providing the food, but you do not have to just talk about Microsoft products. This is all about AI, ML, IoT. And so don't feel that just because you're in a space with Microsoft written everywhere and the organizers work for Microsoft and we're standing here in our Microsoft t-shirts, that you have to talk about a Microsoft product. I mean, I'm on a Mac, for goodness sake, you know. So if there's anything you want to share that's not Microsoft, that's totally fine. Although it's Microsoft space, we're not just Microsoft. So that's my intro spiel. Any questions, comments, thoughts before we dive right in? No? Okay, let's dive right in and dig into my Subtitle shirt, which I would be wearing right now. But for those of you who are here just before we kicked off, you may have seen I had a few wiring problems, which I got resolved, and I don't want to put the shirt on in case it breaks again. But the idea of my Subtitle shirt is, you know, especially in this time of pandemic where folks are wearing masks, sometimes you can't always hear what people are saying. So the idea of this shirt is, if I could say something and have it go across my chest, I get live subtitles. For folks who are hearing impaired, it might help with accessibility. Just wearing a mask might help with that. So just thought it'd be a fun project to do to kind of show off things you can do with a bit of AI, a little bit of IoT, and a few lines of code. So this is the project I'm showing off today. As I said, my name is Jim Bennett. I'm a Senior Regional Cloud Advocate at Microsoft, which is a job title that no one outside of Microsoft knows what it means, and most people inside of Microsoft also don't really know what it means. But essentially, my job is to do this. This is my office. This whole space is my office. I'm here to support tech communities in the Pacific Northwest, whether that's through giving talks here, giving talks online, or just being there to support you. So if you've got a tech community, you want someone from Microsoft to help with, whether it's guidance on running events, whether you want technical help, speakers, come to me. I'm here to help. I'm all over the internet at Jim Bob Bennett, fairly friendly chap. So you can always reach out to me at any time. My DMs on all the platforms are open. So again, if you want, just reach out. I'm here to help you and support you. Now, if you want to recreate what I'm going to show off today, aka.ms/Jim's Subtitle shirt is your friend. This will take you to a GitHub repo with all the code that I'm showing off today, along with a link to a video of when I gave a similar session about this a few weeks ago on the Microsoft Reactor live streams. So that's where you can go to get all the code. And at this point, I'm going to stop the slides and actually show some things off in action. So when I go to my thingy, just going to run some code and demo my shirt. Give me a few seconds while it starts up. And then camera. So this is my shirt. Everything I say streams across the front of my shirt. Now imagine if I was, wearing this and you can kind of read what I'm saying. Yeah. Apologies for being bright. I didn't know what would be the right brightness for the room. So it is a bit bright. We can turn that down. It's pretty cool. It's pretty cool. I have to speak slower because obviously the subtitles scroll at a slower rate. But it's pretty cool. So that's my Subtitle shirt. So should I show you how I built it? Should I actually dive into how I put it all together? Let's do that. Let's do that. First thing I'll do is let's just cancel. Let's just stop that. Take this off. Anyone remember having little Bluetooth headsets? This was all the rage. This is what you wore to talk to your phone. Now you can use it to talk to your shirt. It's very cool. So how does this all work? How does this all work? So in terms of hardware, I have based everything around turn off that light a second. A device called the Raspberry Pi 02W. Oh, hopefully I won't accidentally break any cables when I do this. I've got it inside a, come on, green screens. Press the right button. So inside this little box here is a Raspberry Pi 02W. So this is the size of an entire computer. Raspberry Pi is a British company founded with the intention of teaching kids how to program. And so what they wanted to do is provide the cheapest possible computer hardware that a kid could use with whatever else they have in their house to learn to code. And so thinking about what you'd have in the house, you're probably going to have a TV. And so they designed it to be plugged into a TV. And then it was designed that you can have pins, you can do electronics if you wanted, if you had access to bits and pieces, but then you plug it in and you actually could code on this device. Now, the first Raspberry Pis, they retailed for, I think it's about 25, 30 pounds, which is about 40 bucks. And they ran Linux, a full desktop version of Linux. So you take your Pi, you'd buy a keyboard and mouse to connect to it, you plug it into your TV, and you'd have a full version of Linux running on this Pi, and you could learn to code. And they encourage folks to code in Python or Scratch. And they built a whole curriculum. Now, since then, Raspberry Pi has just gone insane. They expected to sell 30, 40,000 Raspberry Pis. They're selling, well, they were selling about 7,000 every month. Sorry, 7 million every month. So, the scale has gone up. They've been hit by supply chain constraints recently, as I know a lot of the world has done. So they haven't sold so many because you cannot get them for love nor money. And there's a lot of problems with the suppliers getting hit by scalpers. So if you actually want to buy a Raspberry Pi from some companies, you have to phone up and ask for it because they want to stop scalpers automatically buying them and selling them for 4 or 5 times the price. The latest Raspberry Pis, you buy a Raspberry Pi 4. It's got a quad-core 1.5 gigahertz processor, 2 gigs, 4 gigs, 8 gigs of RAM, all runs off an SD card, runs Linux, sets you back. The base model should be 35 bucks if you can get one. So they are designed to be very low-cost computers, and they are. They're powerhouses. Yeah, I could do most of my day job on a Raspberry Pi 4. Yeah, I could take Teams calls on there using Teams on the web. I could program. You can run Visual Studio Code on a. Oh, it's my computer going to sleep. Corporate policies on computers is they go to sleep after like 10 minutes, which is less than that, 5 minutes. And so, yes, they're really, really powerful machines. And they've produced one called the Raspberry Pi Zero. So the first version of Raspberry Pi Zero was designed to be a $5 computer. And actually, they gave it away on the front cover of a magazine. You bought Magpie magazine, which is the Raspberry Pi magazine. You buy that magazine for like $6 or $7, and you get a Raspberry Pi Zero on there. And that's small form factor board, still runs Linux, still plug into your TV, but it just does everything. Latest incarnation of that is the Pi 02W, $15 computer, and this is what I've got here now. If you know about Raspberry Pi, this is basically a Raspberry Pi 3, which is kind of their previous version in a teeny tiny form factor. Very low power usage, tiny little board. If I just pop this out, the case open, and try not to knock out any of the cables. There we go. That's what it looks like inside. So that is an entire Linux computer. Runs a full desktop version of Linux. Got a special port for plugging in cameras. Everything's done off an SD card. It's a great little computer. Absolutely fantastic. And brilliant for IoT. It runs Linux. So any programming language that you can use on Linux, you can use on a Raspberry Pi. So it doesn't matter what language you use, you can code in anything. Fantastic general purpose Internet of Things devices. And they use commercially as well. They sell a compute module, basically a board that's designed to be used in industrial hardware. They're used in a lot of cases. They're fantastic. So my Pi is connected to this LED panel through some cabling, which was causing me a headache earlier. This LED panel is a WS2812B panel, which is addressable LEDs. So what that means is I can individually control each one of these LEDs on here. And they start off at 0 and go on from there. In this case, the panel, it kind of loops up and down. But what's nice about it is the very first LED in the chain is 0, and it goes up from there. So if I've got 256 here, if I plug in another set, this set goes 0 to 255. The next set, stop going to sleep. The next set goes from 256 to 511, and the next one from 512, and so on. So you just keep on adding more and more and more. You can cut them to length, keep adding more. So they're kind of useful. Wake up, computer. They're really, really, really great bits of hardware. They have a number of connections on the back. One, power. Oh, did I lose my sharing? Oh, so people on the call, apologies about that. Where it dropped where, yeah, let me see if I can change that setting. Normally it won't go to sleep when it's plugged into external screen, but it's just, I think there's some energy saver setting that has, where'd they hide all the energy stuff? Oh. There we go. Put that for a long time. Cool. Yeah, so, oh yeah, it's back on the camera, wasn't I? Back on the camera. So the connections here, this has a number of connections. It's got power connections, which I've got running to, it's just a standard USB plug. So it's powered over USB. It runs on 5 volts. So this is just plugged into a USB socket on a power bar, but you can drive it off like a little power pack. So you get a few hours of usage out of just standard battery, phone charger type power pack. And the other connection is a control wire. And that control wire I can then use to program the LEDs and turn them on and off. So when I wire it in, I wire in power and ground the power socket, and then ground and a control wire into my Raspberry Pi. And that allows me to control everything. Now, to put this in a wearable, a bit of Velcro is all I need. I've got some Velcro stuck on the back here. Velcro onto a shirt, hole in the shirt, the cables to go in. Nice long cables, and I can then put the Raspberry Pi power packs in a pocket somewhere, and then I can walk around with the shirt on. And then, yeah, ideally you want to tape down these cables so they don't keep coming out and we get the problems like we did earlier. But yeah, nice long cables. So if you're ever doing anything with wearables, you need to think about where's the power going to go, where is the control circuitry going to go, and also how do I wash it? The reason for using Velcro is I need to be able to put this in the wash. And so I can't put the electrics in the wash because that's, I don't want to toast my Pi Zero. This is impossible to get hold of right now. I don't want to toast the LEDs. So that's why the Velcro, so I can take the electrics off, wash the clothes, and then put the electrics back on. So anything with wearables, you have to think about the electric. Now, software-wise that runs on this, I'm using .NET. It's all programmed in C#. Python is usually the language of choice for Raspberry Pi, but the libraries I'm using just happen to be available in .NET and are slightly better supported in .NET than Python. So I'm doing everything in .NET. So let's actually write some code. How about we actually just start off by just doing a hello world with this particular LED panel. Now, as Michael pointed out earlier, I'm on Visual Studio Code connected to my Pi. So here I am, I'm on my Mac, my Microsoft issued Mac. Any developer, any platform, Satya said that, and he's the boss. So I'm on my Microsoft issued Mac, I'm running Visual Studio Code, and I'm using an extension called Remote SSH. Remote SSH allows me to remotely connect to any computer that's got an open SSH connection, and then access that computer and run on it as if it is my own. And so here, the terminal I've got in VS Code is on my Pi Zero. I'm on my Pi. If I open a folder, if I go here and open folder, the file browser is browsing the files on my Pi. If I run code, it runs on the Pi. If I debug code, it debugs on the Pi. So although I'm on my Mac, I've got all the power of my Mac to run the UI of VS Code. Everything runs on the Pi, which is absolutely bananas, but absolutely brilliant. So let's write some code. And then if I could, yeah. So let's just create a folder, do that in, and then let's actually open this folder. This will open up. There'll be a nice little empty folder in there that we connect to. Cool. Nothing in the folder. Bring up a terminal. And let's create a brand new .NET project. .NET New Console. So if you've come across .NET but don't really know much about it, it's a whole runtime application developer framework that supports a number of languages. Now, historically, .NET and kind of C#, the main .NET language, has been associated with enterprise projects running on Windows. So to a lot of folks, .NET is what you use to build desktop applications you would run on Windows. And if you remember, I said this is a Linux device. I'm running Linux, but I'm running .NET. .NET is actually open source, and it is available on pretty much any platform. You can run .NET on Mac, Windows, and Linux. So I'm using .NET running on Linux. It's pretty cool. From my Mac, I'm using VS Code to connect to a Linux device, and I've just used .NET to create a new application. So much for the old-fashioned, boring enterprise Microsoft day. And so in here, now that I've got my console app, I'm just going to add a couple of NuGet packages. NuGet, if you've not come across it, it's a package manager for .NET. Allows me to use other people's code. In the case of the package jimbobBennett.neopixeltickertape, that's my code. It's available for everyone to use. So while it's doing that, let's just drop a little bit of code in. Do a simple hello world using the ticker tape. Now, one little point to note, I don't know if you see this box down here. There is a C# extension for VS Code that allows you to do all the debugging and things like that. It doesn't actually run on the chip that's inside the Pi 0. So I can't debug this code on the Pi 0. The hardware, it's an older chip to keep the price down. So I can't debug it. For the Pi 4, I have no problems, but the Pi 0 can't. But just dropped a bit of code in here. This is the basic structure of my program. This is a simple empty program, doesn't do anything. Got my little main function there, doesn't do much. Going to just declare some pixels, WS2812B. So this is using a .NET IoT library. So the .NET team at Microsoft have actually built a set of libraries to interact with IoT devices, including the WS2182B NeoPixels, the LEDs that I'm using here. So there's a whole library that allows me to work with those. Now, when I connect to those, let's just drop in a little static constructor in here. When I connect to those, there's everything called SPI. SPI is an IoT connection protocol. It's designed for peripherals, devices in an IoT device to talk to each other. It's how you talk to sensors and things like that. It stands for Serial Peripheral Interface, and it's based around you have one controller, which is usually like the board that you're running, and you connect multiple peripherals. And these peripherals can be sensors, actuators, kind of any other device. And it's designed so it's got its own clock signal to sync all the data up, and you can send data and tell it which one you want to send it to, and all manner of cool communication. And this is what we use in the IoT library to talk to the LED strips. Really, from an end user's point of view, we don't care. We just set up our SPI and connect to it. That's all we really care about. And then once I've got that, I can just do some that connected. What I can do in here is just do a hello world scroll text. So ticker tape writer, library I've built that actually knows how to write text to an LED panel like this. I kind of have to define which LEDs light up for each letter and how that then maps to the way that the LEDs are designed. I wrapped it up in a package for you. So I do that. I'll then do .NET run. And then if I zip over here, what we should see in a second, this out of the way, we should see hello world go zipping across. Too many cables. Should see hello world go zipping across there in a second. Clicking. Yeah, something with a HVAC system. We've raised it with facilities, and we're trying to get it to go away. There we go. Hello world. It's a few lines of code, and my hello world is working. What are we? 36 lines of code all in. So it's just connecting to the LED strip and sending hello world over. But the whole point of this is a subtitle shed. This should give subtitles for what I say. And so I need a way to convert the audio, the noise that comes out of my mouth, into text that I can then display on the screen. And this is where AI comes in. This is an AI, ML, and IoT meetup. So we've got a bit of IoT. Let's add a bit of AI. Now I'm using some Microsoft products, unsurprisingly, because I work for them and they pay me, so I kind of encouraged to use their tools. But Microsoft has a set of tools called cognitive services, and these are pre-built AI. So the idea is we've got super smart people. Most of them live in building 99, which is somewhere over there. researchers and all these absolutely brainy people, and they build fantastic AI models. And then they host these up in the cloud in all our amazing data centers that do all the cool things. And then we, as mere mortals who cannot, well, me in my case, as a mere mortal who cannot comprehend that, I'm sure you're all smarter than I am. I just connect to these AI models with an SDK. So I can literally have an SDK and I can say, do the thing with whatever data I send, and these AI models in the cloud will do the thing for me. Really, really cool. I do not understand how AI works. But I know how to call these SDKs to make it work because I like to cheat. So this is kind of the ultimate cheating with AI. And cognitive services covers a whole raft of different types of services. We've got image-based ones, we've got knowledge-based ones, and we have speech-based ones that do things like audio stuff. So we have all these lovely speech services that will do things like speech to text. Ka-ching, this is what I want. Or text to speech, if you want to give your app a voice. Speech translation, which we'll dabble in a little bit later if you get time. Custom keyword for, anyone ever shouted, Alexa, do whatever? We've got stuff to actually build that kind of thing for you. So if you wanted to build a custom keyword, you can build that. Speaker recognition, questionable area, probably shouldn't be used for banking. Some folks do. But a lot of cool stuff we can do with these AI models around speech. And I can use speech to text in this project to build up my subtitles. So I can create one of those. This is the Microsoft Azure portal. It's like a UI for me to interact with cloud services. And I can create a speech resource in here that I can then use in my code. Go in here, type in speech. Yeah, that's the one I want. Speech by Microsoft. Create one of these. There we go. Now, whenever you create any kind of resource in Microsoft Azure, you have to put it in what's called a resource group. This is like a logical grouping of resources. So the idea being you would put all the resources for one project in one resource group. So it means you can find all your things. Look at the resource group, there's your things, but also you can delete your things. At the end of today, I can delete my resource group and that will take away the services that I create. And once they're gone, I don't have to pay anymore for them. So you have to create a resource group. Got one of this. Choose where in the world you want it. Microsoft Azure is not just one building. Yeah, Azure is not just over there. We have it in, I think, over 60 different regions around the world in multiple countries. And so I can choose lots of places to spin this up. Yeah, speed of light is fast, but not that fast. So when you're sending data, you want to send it to the closest location to where you are. So I would choose somewhere to put it. I'm going to stick this one in West US 3, somewhere in the US. Then I have to give this a name. Now, this name forms part of a kind of unique identification for this particular service. So it kind of needs to be unique. Subtitle shirt. Kind of have to give it a unique name. It's just the nature of the beast, so you can identify your particular thing. And then pricing. Then I choose pricing. And I'll just show you the pricing because guess how much this costs? Anyone? Yes! It's almost like you've probably come across some of these sessions before. Yes, a lot of these services have a very generous free tier. So you can get speech to text, 5 hours free every month. So if once you hit more than 5 hours, we don't just charge you, that's it. It's just end of 5 hours, we just block you. Don't get any more. So you don't get any sudden bills because you leave everything running. And that's 5 hours free of what it sends. So the SDK, if you saw it was obviously, but we're using this. When I speak, it listens for that volume. I will speak for like a minute, whatever. It sends that minute to the cloud. If I say nothing for the next 20 minutes, that doesn't get sent to the cloud. That's all. It kind of detects my voice, detects whether I'm saying something not locally, so I only get charged for what goes to the cloud. But 5 hours for free is pretty good. And then if I want more than that, I can pay. But why would I do that? I can just choose a free tier. I then click create and I'll go up and create this. I'm not going to do that now because I've already got one, and you don't want to see this spending 10 minutes just spinning, doing its thing. Just a bit less than that. It's about a minute. But I've already got one. Any Brits in the audience? I'll do my best Blue Peter. And here's one I made earlier. If you're not British, you probably won't get that. There was a kids' TV show called Blue Peter, and they used to teach kids how to build things, like build like a rocket out of a washed up liquid bottle and stuff like that. And they would describe it, and here's one I prepared earlier, and then pull out a perfect one underneath. So yeah, so the magic of TV, yeah, same kind of idea, yeah. So here's one I prepared earlier, and when I connect to this, I have these keys and kind of endpoints. So it's all here. So this is kind of how I connect to it. As I get authentication, because I need to prove it's mine, that I'm going to pay for it. Obviously, free tier, I'm not paying much, not paying anything. But this is how I kind of connect to it. So once I've got this, I can then use this in my code. And the way to do that is via the SDK. So, I don't want to be running these AI models locally. I want to use an SDK and use that to access it. So the .NET add package, Microsoft.cognitiveservices.speech. Nice little SDK that does everything I need to interact with the speech service. So while that's all stored in the package, I will then just drop in some using directives, just to say I want to use this code. And then I have to add my key and region. So this is the kind of the security side of things. Yes, this is my key. You can all see my key. Everyone on the stream can see my key. I am so rotating this key at the end of today's session. So I'm intentionally showing it to illustrate how this works. This is a free tier, so you won't cost me any money if you steal it. But at the end of this session, I'm going to rotate this. So don't get any ideas. So that's my key. Once I've done that, and you just need to actually configure how I'm going to process the speech. So in here, I'll just put this in here. I have to configure how to do it. So I'm saying I want to set up my speech service using my key and my region. I have to tell it where it is. And then I tell it what language I'm going to be speaking. So that's actually correct. This should be ENGB. I'm speaking English. Yes, so the question here. Let me grab a microphone for the question.
So when you configure the language, are you able to have it auto detect which language, or you must specify?
Yeah, so great question. The question is, are you able to have it auto detect the language? We do have language detection as one of the capabilities. So yes, you can do it to detect, you can actually get it to detect a language. Obviously, it's more efficient if it knows what language you're going to be speaking up front. Difference between ENGB, which is British English, and ENUS is essentially negligible, except the model is trained on slightly different accents. But yes, you can actually have models where it will work out the language for you. We're just not doing that. Not doing that here. Yeah, great question. Yeah.
So speaking of accents, does that also detect different accents in the US? So someone over here in Washington might have a different accent than someone, say, down in Georgia.
I guess so. I mean, I've seen a number of people with different accents show off this service, and it's not had any problems with accents. It can be problematic if somebody is speaking a language that's not their first language. So if you have a strong accent from, so like, say you're speaking English with a strong French accent, that can confuse it slightly. It's like the Amazon Alexa can be confused by a woman speaking English with a Zimbabwean accent in the case of my wife, which is why she never gets the music put on that she ever wants to listen to. But no, so it can be thrown by some accents. But yeah, these models are usually trained on as geographically diverse range of voices as possible. So the UK, for example, very small part of the world, a lot of different accents, and I've not seen people have any problems with it at all across the different accents. Yeah, great question. And it'd be a great one to kind of line up some of the research folks and dig into that a bit more. Yeah, no, really good question, actually. So with my config as well, I need to tell it what to listen to. So this has got to listen to something because it's got to detect my voice. And so I have to set up an audio configuration and tell it what piece of hardware to listen to. So this is set to plug HW:1,0, which for most normal humans is meaningless. Now, it's a Linux thing. So if you're a Linux expert, if you've done a lot of audio in Linux, then this will make total sense to you. But for those of us who haven't, this really doesn't make much sense. But there's a thing called a record, which is a Linux, if I could spell, a Linux tool for managing your recording. If I run a record -L, that lists all my audio devices, and card 1 is a BT600 Plantronics USB audio that's got device 0, subdevice 0, subdevice 0. Which makes sense to people who understand ALSA configs and Linux stuff like that, which I don't. But what I do know is if I put in plug HW, the card number, and the device number, it works. So that's how I identify which particular audio device I want to use, and that tells it what to listen to. That particular device is this headset. It does Bluetooth and has got a little dongle that's plugged in. So that's connecting to the dongle. So once I've got that, I then actually build my speech recognizer, give it the audio config and the speech config, and then I then listen to an event called recognized. So when this runs, it'll do its thing, and then fire an event called recognized. When it's done, and then when this recognized event is fired, there can be a reason why this is being fired. And the reason, if it's recognized speech, we'll spit that out to the console. Once that's going, I just need to actually start it listening. So just dump out the console to say speak, and then actually start the listening. And this will run asynchronously, run off in the background and just do its thing. If you're a .NET programmer, you know about async and await. You'll see this go, oh yeah, this is running in the background. And of course, because there's nothing else after this, my application will stop because there's nothing to keep it alive. And so I do have to kind of put some kind of event loop, while loop type thing at the end, just to keep the application running. So drop that in there. And that just sits there in the background, just keeping the application running. Now, if I run this, like that, and then don my Bluetooth headset, I look so cool if I was 20 years ago. So in a second, this will build. One downside of the Pi Zero is it is not a very powerful device. So if I do .NET run on my Mac, it's just instant. I do it on here, I do have to wait for a few seconds for it to compile. Build it, test it. Any minute now. Hello, world. Welcome to the Eastside AI, ML, and IoT Meetup. So there we go. I'll just zoom in a bit here. It's picked up what I said. So it did everything for me. It listened to the microphone, grabbed the audio, it waited till there was some audio there for it to grab, send that audio up to the cloud, process that in the cloud, and then sent me back the audio as text, which I could then dump out to the console. So that's kind of the basic structure of my Subtitle shirt. So if I then want to write that to my shirt, once I've got the result, I then scroll the text. The result that comes back, this is what I scroll. Let's just run there. Okay. Suddenly we've written, what have we written realistically? 62 lines of code with some spaces and comments and stuff. And we've got everything kind of working, which is pretty cool. Let that just start up. Wait for it to tell me it's ready. Hello, world. And there we have zipping across the chest. Now, there's one problem with this as it is set up right now. Is if I start talking whilst it's still rolling text, suddenly you end up with this weird mess of things being lit up. Because I'm talking, it's processing, and then it's processing something else. And probably if I talk fast enough, I wonder if I can get it to go white. Maybe not. I can get kind of some of the letters to overlap with each other, but probably yes. If you talk fast enough, it just builds up gibberish because it's just constantly sending to. It's just constantly sending it to the LED strip. So the light's being processed. It's not waiting. So this is like a usability thing. I would have to literally say something, then watch the shirt. When it finished, say something else. So it probably makes sense just to tweak the code a little bit to make it do the text, kind of wait till it's finished. And so for that, I can just create a basic queue, nothing too fancy. And then when my text is recognized, instead of sending it straight to the LED strip, I'll just put it into a collection, put it into a queue, and then kick off another background job. do like async and await in .NET. It's great. You just a few lines of code. Here you go. Here's a background job just running. Kick it off. Runs the background. Done. And so this will sit there. It will constantly try and dequeue things from my queue. So I speak, goes on the queue, and then this job will sit there every and again, pull it off the queue, write it to the t-shirt. Pull off the queue, write it to the t-shirt. So it'll kind of queue up my text a little bit. And so if I just take that and run this, give that a second to build, I will then better speak to my heart's content without worrying that it's going to overlap the text. No, that's not. It's not asynchronous. Yeah, try DQ is not asynchronous. Oh, the in queue. No, no, it's concurrent queues designed to be accessed multiple threads, but there's no. It's not asynchronous in the way that you add things to it. I always thought it was, so I was there waiting when I wasn't compiling.
Will you ever run into a problem with things going into the queue out of order?
No, that shouldn't happen. Because it's got the time it takes to send my voice, the cloud, process that, come back, and then add it to the queue is basically instant.
Okay, so if you sent a paragraph of text and sent that off and then sent a word, could the word potentially come back before?
So the reason I was pausing was to actually kind of try that out. So I'm saying a long paragraph of text to see what happens. Hello. That's the thing that, because it detects me stopping speaking, that pause is probably long enough for it to not get out of sync. But that'd be a good experiment. I could just try talking for a long time and see if I can kind of beat the system and game that. But I mean, this does force me to speak slower because we want the subtitles to be in time with what I'm saying. So I do need to be a little bit conscious of what it's showing. Yeah, good question. That's a challenge for myself to try and do that. Cool. So that's the basics of a subtitle shirt working, which is very, very cool. We've got a Raspberry Pi Zero, we've got an LED strip, we've got a little bit of code here, 77 lines of code, and we've got the whole subtitle shirt working. But this is great. This is great for people who want to read what I'm saying. You know, people with hearing impairments, for example, might find it beneficial. Also, people for whom English is not their first language. You know, we find that a lot with things like captioning on tools like Microsoft Teams, for example. Some people use the captioning because English is not their first language, so they want just that extra context, the extra understanding of what's being said. But what if maybe, say, French was your first language? Wouldn't it be nice if what was going across my chest was translated into French for you? Imagine if I could automatically, on the fly, speak in English and have it go across my chest in French. Should we do that? Should we do that? We can do that with exactly the same speech service. What's really cool about speech service is it supports translations out of the box, which is just, it's bananas, absolutely bananas. So the first thing I do is I change my configuration. So we had the speech config, which had the recognition language. What I add now is a translation config, still got a recognition language, but it's also got a target language. And I can put one or more languages in here and say, I want this to be translated. So I can do multiple languages at the same time if I want to, which is pretty insane. Then once I've got that, I change my recognizer. I don't want a speech recognizer. I want a translation recognizer. It's a slightly different object, but otherwise it's the same. Takes my config, my audio config. And then I just need to tweak my recognized event because I'm not looking for recognized speech. Instead, I'm looking for translated speech. I look for translated speech. Then when it's translated, I get back translations in a dictionary, and it's keyed off the language. Now, one thing that's not so great here is it doesn't deal with the different dialects. So we have French. I can only request French. I can't do Swiss French, Canadian French, or French French. I can only do French. What would you call French French? I guess it's because yeah. But what about rural French? People that are not. That is, yeah, that's true. Actually, there is difference. So I actually don't know whether it would be Parisian French or whether it would be. Yeah. So the question was, how do you differentiate between the formal and the informal in French translations? I have no idea. I am not an expert in French. I can just about order a coffee. I couldn't tell you any more than that. So I don't know. I don't know what how it's trained. Do you? Yeah, so as long as I say something that's not going to be plural, we can try that. We can try that. Here we go. We're trying linguistics as well. This should be a bit of fun. So yes, this is basically all I need to do. It's literally, I say I'm using a translation config. This is the language I want, different recognizer and different event. And that's literally the only change I need to make. And if I run this, we'll see it. And then we can try, as you say, whether it's formal or informal. Now, one thing I will say is the library I've built to use the LED panel only works with Latin characters. Just because I've had to define every single bitmap for the letters, and to do that for the entire Unicode character set was just too much work for now. So it just does Latin characters. So if you want me to translate it into, say, simplified Chinese, I don't have the character set available for that yet. But over time, I want to build up the character set. Limitation is we've only got 8 pixels high. So I need to make sure that the characters could fit in that space. But at the moment, it's just set up for Latin characters. Oh. Why are you complaining? Okay. Shouldn't be. Unless they've moved something in the, since earlier on today. So copied and pasted them wrong. Just checking. I think it was. Oh no, you're right. It is a different namespace. One of those days today. Yep. Good call. Good call. So let's try that again, folks. Now build. On my gorgeous Bluetooth headset. Hello, world. Oh, hello, world. Its connection to the headset. I might need to restart that. Oh, there we go. Oh. Hello, world. You are amazing. There you go. Just using the informal. So those who don't speak French, there's 2 ways of saying you. There's tu and vous. Tu is the singular, vous is the plural. But there's a more formal way when you speak to people that you use vous as kind of a polite way of saying you. And then you normally get invited to use tu by somebody. That's kind of a way of saying yes, we're friends. But those are the kind of there's a relationship as well that kids would use vous to talk to an elder, whereas they would use tu when talking to kids. I never really understood the rules of it. But yeah, here's lots of French being streamed across across my chest. But you saw it only took a few lines of code to change that. Now we support a whole load of different languages with this. Whole load of different languages. Where's the list of languages? Here's the list of languages. Look at all these languages. We have a whole load of different languages, a whole load of cool different languages. We keep adding more all the time, which is really, really cool. So, I mean, what have you got? Everything from Zulu to Afrikaans. So, Maltese, Malay, Persian, Serbian, lots of versions of Spanish, Ukrainian, Vietnamese, lots of different languages that are supported.
Is that the list that you can input or output or both?
So this is the speech to text list, actually the translation list. We've got a list, a whole list. There you go, that's all the translations we can translate into. So, want to translate it into Telugu or Spanish or Samoan, we've got that there. And particularly, I'm going to just add this one for any nerds in the room. If you think you are fully nerdy, then I'm going to add this one here. And then I'm going to put this one in. And does anyone know what the language TLH is? TLH, come on. Let's see how nerdy you are. What would be the nerdiest language that we could support? The answer for the room was Klingon. And yes, this is Klingon. So when it pops up, hello world. That is hello world in Klingon. So that's how nerdy we get. We can translate it into Klingon. So there you go. That is my Subtitle shirt. We've talked about the hardware, the Raspberry Pi, the $15 computer that makes this all happen, the LED panel. These are about $20 the panel. On a shirt, held on with Velcro so I can wash my shirt because otherwise that'd be gross. And then we've got, all in with all our translations as well. We've got literally 81 lines of code. We're using a service in the cloud. I speak, it takes what I say, sends to the cloud, and then brings me back the text that I can scroll across the LED panel, or I can translate that into Klingon. And that's what we've got zipping across right now is me speaking in Klingon. So that is my Subtitle shirt. Thank you very much for joining me for this. So I hope this was a bit of fun, and we're open for questions. Before I take any questions to the room, Casey, do you have any questions online? Nothing online. Okay, Michael, yeah. Oh, thank you.
So for an added challenge, can we translate from English to another language and back to English and see what, because that always has interesting results.
Yes, we can. For me to do that, because this is based off, why this is based off audio, I would have to write a whole lot more code, which I won't do right now. But yes, you can do from one to the other, and you do get the discrepancy between how the language is translated. But it does mean, just think about the whole kind of translation thing as well. The idea of a universal translator becomes a viable thing, because I could then build a device. I speak into the device in English, it gets it translated, and if I can have 10 other people connected, all with their own language choices. They send me the language choice, I translate it, and then everyone gets to hear the language coming out, which is pretty cool. But yes, we could do that. I don't have the code to hand, and you probably don't want to watch me digging through docs for 20 minutes trying to do it. But certainly we can maybe do that in another session. We actually do that, just see how different it is. Because these models are usually trained on well-translated documents, like books, for example. Here's a book that's been professionally translated. We kind of use that to work out how to train the model, and you're always going to get discrepancies as things go. Like when I did French, for example, I said hello world, and salut tout le monde is more, salut is more of a hi than a hello. So when you translate that back, you might get hello world, you might get hi world. It's kind of, we don't have that kind of necessarily one-to-one word mapping. So there will be discrepancies. I'd be interested to see how many times, if you went from English to French to English to French to English to French to English to French, just how much garbage you would get coming out the end. Yeah, great question. Question back there?
Looks like this requires an internet connection. Can this model of the library or text-to-speech can be downloaded and be done in the offline mode?
So this particular one, yes, you can download it as a container. So if you ever use like Docker containers, you can download this as a Docker container. But even then, you do need an internet connection because if you're running our model on your own container, we still want you to pay for it. So we do require that your container connects every now and again just for billing purposes. So in terms of like processing the text, everything I say has to go to the Microsoft, has to go to Azure, has to go to Microsoft Cloud. I changed you. Why are you? Sorry, I need to share my screen again because I don't know why it went to sleep. So everything I say has to go to one of our Microsoft Cloud regions. So if we're thinking about kind of privacy, if I'm doing medical information, things like that, the lights going right now, I can turn them off. Things like medical information, then I wouldn't necessarily want to send that up to the cloud. I want to run that locally. So for that, you would download a container, run the container locally, but you still need that internet connection just for billing. Because I said you get like 5 hours for free, and we charge you after that. That applies whether you run it in the cloud or on a container. And obviously, there's a load of other solutions people have done for this. Your phone has speech-to-text capabilities, so some people do run it on their phones. Whether our models are better than the phone, I don't know. Certainly, what we see is they are. You think, despite how powerful these phones are, the cloud is more powerful. So I've seen other people doing similar things, just using their phone for this. But if you want to actually use our models, you have to pay, which is why you have to. If you are running a container, you have to have a connection. I don't know how often it connects. It's every few days it connects just to make sure billing-wise you're doing the right thing. Cool. Any other questions? Yes.
So earlier mentioned that in order to do this, you found yourself speaking slower so that it could catch up, so that they could read it. Have you found that even when you're not using it, that it has affected your communication style in every day?
I haven't worn it enough for it to make much of a difference. Yes, but I have been told many times I do speak too fast. So it is something I'm working on. But yeah, I think one problem with relying on the timing of the shirt is it felt artificially slow. So when I'm wearing it and I say something, I have to kind of talk this slow so the text is scrolled across my chest. And so that kind of feels a bit artificial. So my next plan for the next iteration of this is to maybe add more panels so I can actually have multiple lines of text going. So you think about if you're watching a video with subtitles, normally you have multiple lines. If it's long bit of text, you have multiple lines there. So can I get maybe a more dense panel to kind of show more text? Or can I get to do something that's a bit quicker so that it appears at the same speed that I'm speaking? That would be a lot more natural. But it is kind of artificial, the waiting for the scrolling to finish. You see what I mean? It's kind of, it's great for those who are hearing impaired because they see everything, but for everyone else, it gets a bit artificial. So trying to be more inclusive with tools like this, I need to do it in a way that supports as many people as possible. And I don't want people to walk away from me because I am pausing for such a long time to let the text scroll. You see, it's kind of hard to just listen to me like that. So they won't even care what I'm saying, really. They'll be too busy watching that and then half expecting to see the Tantive 4 disappearing in the distance with the Star Destroyer behind it. Imagine that, having just Star Wars on your chest, just walking around playing the movie. Who wants to build that? Who wants to build Star Wars on their chest and actually come up here and do it? Any volunteers? Yes. Yes, people actually built ASCII converters. There's something actually you just upload any movie to it. But yeah, the Star Wars was the first one, wasn't there? That's the whole thing in ASCII. So if I could get this high enough resolution panel, I could have ASCII Star Wars playing on my chest at all times. And then no one would care what I'm saying because they're too busy watching Star Wars. And then it would be really unfair because I want to watch Star Wars and I can't because I can't quite see it, but doing that. Awesome, cool. Any other questions? Anything online?
Mentioning how fast you talk and how slow it scrolls, could you actually adapt the speed of your speech to the speed that it scrolls?
Okay, or vice versa, I guess. Adapt the scrolling to my speech.
Uh-huh.
Yeah.
Yeah.
I mean, so the library I've built does have the sort of number here is how much gap there is between each frame update. So if I set that to be a much higher, a much lower number, for example,
Does the cognitive service even recognize the speed of your speech?
I think it does allow me to get the length that I'm speaking. So I think it does do that. So if I say something, you see it's now going 10 times, it's now going much faster, kind of less of a break. So I could speed up the text. But the problem is you need that pause, the text to go up to the cloud and be analyzed. Because one problem, if you've got text and you're trying to convert text into speech, you need to have a lot of context around what you're saying. So it can't just send a few words. It has to send, it has to kind of send a whole sentence. And there's event to get fired. I look at go back to my code, where I've got my, so the original code, we had the recognized event. There is a recognizing event that gets called. And so as you start speaking, the words kind of form. So you might get a word, and then when it's got more context, it might go back and change the word. Like autocomplete, sometimes as you're writing something, it may go back and change a word because it understands what you meant better because of the context. It does that. So I could actually have the sentence slowly appearing on my chest as I was speaking, which then may get over that kind of pausing, because I have to pause long enough for it to identify that I've stopped speaking and then send the text up to the cloud. So it's not just the scrolling time, it's I need that pause so if it knows for it to actually stop and process everything, which I could get around by just listening to the recognized event and just have it constantly updated on my chest.
And if you know the character count combined with the length of recording, you could potentially get a very basic level of slow, fast, medium.
Yeah, it would customize. It would then customize to, as I'm speaking, it will scroll at the right kind of pace. And then we combine it with your shot collar idea from earlier. If I'm speaking too fast, slows me down. Perfect.
Exactly.
Awesome. Any other questions? So it's built into the speech recognition library. So I don't know whether that can be configured or not. I haven't seen any configuration for it, so I don't think it can be configured. It's just part of the library. Oh, thank you.
After this pause, to be more efficient to send the audio to the cloud, they are recognizing that pause to send it to the cloud, because you don't have a real-time connection or a TCP port, TCP connection to the cloud with audio in real time, streaming the audio in real time to be translated. It's just a HTTP call with the audio stream.
So no, it does actually send it in pieces. So when it actually starts speaking, it will actually start sending the audio, and then it fires an event called recognized. Let's show. If I just get rid of all the translation stuff, go back to the old one. I believe what we've got is, I think it's recognizing is the event. And then I think that's the right event. If I do that, and so it will actually do it. So the Python library does. I haven't actually done this with the .NET library. The Python library does. It does actually process it in real time. So you can actually watch the sentence forming. But let's see what it does with .NET. Let's see if it actually even compiles. It may not like that. Recognizing event. I don't know.
Okay.
I mean, we do have a REST API that we access, but I don't know whether behind the scenes or not it's using a different protocol or whether it's using HTTP. Yeah, so that's one of the advantages of using a. Oh, I didn't. There's me trying to remove all the translation stuff, and I'm not actually removing it. Yeah. Okay. Oh, yeah. See, I don't know what it's using under the hood. I haven't dug into how the SDK works because I'm lazy. Yeah, I would rather just access the SDK. Oh no, there is no recognizing. Okay. Yeah, I've done it in Python. You actually see the text build up over time as it processes part of it, and then uses kind of the pause to actually say, "Yep, I've completely identified this particular block of text." Cool. Any more questions? Yes.
Thank you. So I may have just missed this in the code, but how have you connected the Bluetooth where the code can catch all of what you're saying?
So the Bluetooth side of it, although this is a Bluetooth headset, I am cheating. It's actually got a little dongle, a USB dongle. So this USB dongle connects to here. So this connects to here over Bluetooth, and that then appears as a standard microphone. And then what I have in my code here, I have my audio config, and this is where I select my microphone. So just by, although this is a Bluetooth headset, I could connect over Bluetooth if I wanted to. When this gets routed through into ALSA, which is the Linux audio architecture, it just sees it as, if I just run the command to A record minus L to run that, it just sees it as an audio card. So the ALSA internals, the Linux audio system internals, just doesn't care what it is. It just sees it for what it is. It sees the Bluetooth, say, connects the dongle. The dongle then acts like a USB microphone, and then that's just detects as USB microphone by the built-in hardware drivers. And all I care about is that is card 1, device 0, because that then goes in here. It's card 1, device 0. That's kind of a Linux thing. If I was doing this on Mac or Windows, I may have to put in something a little bit different to identify the microphone. That's why it's there as in quotes, as like a string identifier. If you only got one microphone on Windows, it just works, just picks it up. But Linux is a bit quirky. Cool. Anything else? No? Okay, cool. Well, thank you very much, everyone. Thank you for joining me for this. I hope this was entertaining. As I say, I am all over the internet, Jim Bob Bennett. Where's my thingy with my thingies? So yeah, aka.ms/Jim Subtitle shirt. That's the link for the code that I've got today. So that's all up there if you want to recreate this yourself. And then, so I'm all over the internet, Jim Bob Bennett. So if you're not connected with me already on LinkedIn, GitHub, Instagram, Twitter, whatever, feel free to connect. Got any questions? Feel free to reach out. I'm a friendly chap. I'm always here to help out and answer questions for you. With that, otherwise, thank you very much. And anyone who's watching this online, if you missed earlier, if you want to join us for some conversation, we can't give you pizza. We can show you pizza, but we can't give you pizza. But if you head to aka.ms/Reactor Red Networking, you better join an app called WonderMe, where you will appear on one of our big screens here. We'll better see you, hear you, talk to you, and you better see into the room, hear us, and talk to us. So if anyone there who's watching this on YouTube wants to join us, this is kind of one of our experiments around hybrid meetups. So please come and join us and watch us eat pizza. And I apologize for the fact we can't send you pizza wherever you are in the world. So otherwise, thank you very much. And people in the room, eat pizza, and let's try getting this networking thing set up. Cool. Right, so Casey, what do I have to do to do the thing? Ah, cool. Yes.